Hello everyone, today I am going to show how to create an application for calculating the electric potential, electric field, electric field vectors and electric field vectors angle with the Java programming language. This program has 5 class and 1 interface, and it solves different problems about the charts, a lot of charts, a solid consulting sphere and a solid insulting sphere. And finally, I will illustrate how to draw a graph with related it and with external library.
Okay, let's see the code. Firstly, this interface play important role for the calculation because we know constant k value is approximately 9 million, and this value very difficult for the Java virtual machine. If the calculation result is the 10 number, ID say that is unbounded. So we get some different scientific notification. I choose to use only micro and nano coulomb value for the calculating process, so the application very understandable for us. For example, nano coulomb value is 0.000001, and if we calculate electric potential for nano coulomb with the formula potential is equal to K times Q over R, we obtain only 9. And if we use the micro coulomb, we obtain 9,000. We can see that is very understandable. And now here is my point. Abstract class. Abstract, the reason why I don't want to create a new my points objects for every calculation, but if you think it is wrong, you know. But I decide to this way. And now as the charge class extends my point x and y value inherent my point class, and then two attributes q and string coulomb value, and there is a set coulomb value method if value nano or micro correctly setting, but if not, new invariant coulomb value exception, and potential add method. If coulomb value is nano, calculate q times k with the nano over distance xy, and if coulomb value is micro, calculate the k times q micro distance my point, and then electric field vector magnitude. If coulomb value is nano, k times q nano over the second power of the distance xy, distance point, and electric field vector angle method if the angle have or have not. If have not, we reach the not found angle exception, and we calculate the exception using two arctangent methods and electric field vector add method. This is important and complicated method. We know two charges composing an electric field and vector any specific point. We separate each vector's x and y component via the cosinus and sinus operator. Then these two components is added each other. Secondly, we use arctangent function and could define an angle. If the angle does not exist, we find a not found angle exception. Finally, we can print a magnitude and angle for these two charges at the specific point. And then we reached the sphere methods. Again, extends my point and inherit x and y value for the center of the sphere, and set radius set surface area methods, distance methods between the sphere center and the other points we will measure, and we reach at the conducting sphere, extend sphere, and implement I-electric interface. Set Coulomb value method, again the same way in the charge, and electric field vector magnitude method. This is a little bit different method because conducting sphere has not an electric field inside itself, so we have to calculate this situation. If the distance r, sphere center, and point lower than radius, we find a not found electric field exception, and this program's exceptions, all of them extends from the runtime exception. If the points are on the sphere surface, we calculate k times q nano or micro second power of over the second power of the radius, and then if the distance r bigger than radius, we have to calculate k times q nano or micro over the second power of the distance r. And potential at value, potential at method for the conducting sphere. Conducting sphere has a same potential value inside it and on the surface. Firstly, we calculate distance, sphere centers, and points that name is distance r. If the distance r is lower than the radius or equal it, we calculate k times q nano or micro over the radius. If the distance r is bigger than the radius, we calculate k times q nano or micro over the distance r. And then last class, insulting sphere, extend spheres in the same way with the conducting spheres, most of the methods, and different methods are there in it. Get charge density, get parameter x and y. It's important for the insulting sphere because insulting material has different q values inside or surface. So we use this method for the potential and electric field magnitude. For example, insulting shape has an electric field inside itself. This method returns q over sphere's volume. Get q in method. This method firstly create a new sphere that name is Gaussian surface, because insulting spheres each surface different potential and electric field magnitude. So if we want to calculate these forms, we have to know q in, q inside. Electric field vector magnitude method, first again we calculate distance r, and then if distance r is lower than the radius, we calculate the k times q in, get q in method over the second power of distance. If distance r is equal to radius, we calculate k times q over the second power of radius, and if distance r is bigger than the radius, we calculate the k times q over second power of distance r. And then potential at method for the insulting sphere. First we calculate again distance r, and if distance r is lower than the radius, we calculate the k times q inside over the distance r. If distance r is equal to radius, we calculate the k times q over radius, and then we reach the exception class: not found angle exception, invalid Coulomb value exception, not found electric field exception, and not negative radius exception. So how this programs works correctly, if you will understand it, because I prepare 5 problems and 13 sub-problems for it. Problems there are all of them, and then I illustrate how I added an external library for the Java projects, especially IntelliJ IDE, file clicked, and then project structure, and then this file, your file is empty, and then library clicked, edit button, Java, and this library where to download is on your computer. Then click book, library, CP master jars, and OCP master library is a good library, but it has older version for the Java 1.7, but free library and good library, and a little bit confusing, and you struggle it for the newer version, especially array list, linked list. A little bit problem there are, but I am sure you will solve it. Okay button clicked, and then apply, and then close it, this window, and then run the project. Oh, I forgot it. This file scalar 2D frame objects for the graphs, and I created a matrix data, two-dimensional matrix, and it includes 400 points on the coordinate system, and 1 by 1 increasing 2 for loop itself, because if ix loss is equal to 0.1, these programs and the matrix will have 40,000 points, and very difficult for the Java virtual machine, especially for my computers. Okay, and then all the data, gathered it and set all for the frame. Okay, and visible true, and JFrame exit on close, and run it. Questions and answers, and we reached the graphs, and 0 0 my charge, and my second charge x0 and x10, and y is 0, and then 2 plus 2q nanovolt and minus 1q nanovolt. Contour plot, and you see the equipotential surface E charge, and then surface plot, the HD graphs, 3D graphs, very impressive, and then interpolated plot, equipotential surface for each charge. Okay, thank you for all listening to me, and if you want to these codes, you contact me, and you will find on my GitHub page.